So as it stands, our game project is starting to take shape. As of the last lesson, we constructed a beginning of a game world using what's called a grid map. A grid map has a mesh library plugged into it, which is a collection of blocks that we've used to start designing a game level. In this lesson, though, we're going to focus in on our game character, in particular how the character moves and how the camera moves around the character. So in this lesson, we have a few things to do that'll tweak the way the character moves, including, first off, we're going to tweak the game level gravity so everything, including our player, falls a little bit more naturally. We're also therefore going to tweak how our character jumps in the scene and make our character jump with a little more power. We're also going to make it so that you can control the rotation of the camera in your game around your player. So you can press the L and the R keys to make your camera rotate or orbit around the player as you're playing so you can see the game level from different angles. We're also going to change up our character's controls to be in relation to our camera. So if you press the up arrow key to move forward, you always move away from your camera. Likewise, when you press left and right, you're always moving left and right, again, in relation to your camera. And lastly, we're going to make it so that your character always faces in the direction that they're going, which is good. So let's go ahead and jump in. The first thing I'll show you in this lesson is that if I go ahead and play my scene, that everything sort of falls in slow motion. If I jump, well, as I'm jumping and in midair, I'm sort of hovering there for a moment. The gravity in my game level is therefore too weak. It's kind of like I'm on the moon. So what I'm going to do is go into my project settings actually, because if I go onto my game's character, which is where we actually have him programmed how to move, you will see that yes, there is a gravity variable here that defines how quickly my character will move down. However, this variable refers to a value in our project settings for everything, not just the character, but also those falling blocks in my game level. So if I go up to Project and Project Settings, under the first tab at the top called General, if I scroll down on the sidebar to Physics and 3D Physics, you'll see here that we have a value called Default Gravity set to 9.8. Now 9.8 is actually what we're getting in our gravity variable because this gravity variable is accessing this variable. However, I'm going to turn this up for everything in my scene. So if I type in this box, I'm going to try 28, which is quite a lot higher than it was before, and I'll press close. If I save my project, Control S, and go up to play scene, you'll see that everything falls a lot quicker. And if I jump with the spacebar, you'll see that my jump and my falling is a lot snappier. There's no more floating in midair. But because I jump so short, because when I turn gravity up, my relative strength of jump force up is now weaker in relation to the gravity, what I should do is go into my character's code here and change this constant called jump velocity to be quite a bit higher. This is the variable that gives us how much force up we push up when we press the space bar on our keyboard. I'm going to change this value to 12, I think, and I'll press Control S and try playing my game again. Now when I jump quite a lot higher, and I quite like that. It seems pretty good to me, okay? Next up is our camera. If I jump back into my 3D world for a moment and zoom on in to my character, you'll notice that my character, with my character selected, has a very large bounding box. And that's because several lessons ago, when we set up our game camera, we actually set up a few invisible controller and target objects for the camera to help with this next process. If I jump into my character's scene, I'll go ahead and click on his little clapboard scene icon right there to open up his scene in a new tab. You'll see that I have, as a child of the root Steve object, I have what's called a camera controller. This is a node 3D, which is essentially just a coordinate in 3D space that I've put exactly at Steve's origin right here. That camera controller has a child, which is also a node 3D, that if I go ahead and zoom out, is basically our camera target. Essentially, it's where our camera should be and how our camera should be rotated, pointing down at the character. The camera is a child of the camera target, and that makes sense. We want the camera to stick to where it should be and how it should be rotated. I'll also point out that this camera controller is not something that actually sticks to the game player. We've selected the camera controller in an earlier lesson and turned on this top level option, which means that it won't stick and follow along with its parent, the character. We've actually done that with code in our game to make our camera controller always be at the same location, but not the same rotation as the character. That's important. So what I want to do in this lesson is add some controls on the user's keyboard so that when they press keys on their keyboard, let's say the A and D keys for left and right, that we can actually take this camera controller and rotate it on the Y axis like that to spin the camera around the character. Let's go ahead and set this up. However, we're actually going to have to add some new actions into our game project because up until now, we've been relying on built-in actions to detect key presses on the keyboard. Before I jump into showing you what I'm talking about here, let's make sure that our camera controller, with it selected, has a rotation of 0. I went ahead and I rotated it a little bit by accident there, so I'll turn all 3 rotations, especially the Y direction, back down to 0 and press enter. Okay, so if I take a look at Steve's code here, that we have some checks for key presses on the keyboard. We have jumping code, which basically checks to see if the user has pressed the space bar on the keyboard using what's called an action called UI accept. If we check if an input has happened, if they've just pressed a keyboard key, which is essentially bound to this name of an action called UI accept, and the spacebar is bound to this action, and if we're on the floor, then we jump. We also have another check for input for directions on the keyboard, and this one's a little bit different. This method called input.getVector takes all 4 directional arrow keys, which are UI left, right, up, and down for the arrow keys in each direction on the keyboard. And again, all of these actions have bound keys on the keyboard. We can make our own actions though, and we're going to do exactly that for our camera left and right movement with the A and D keys on the keyboard. So I'm going to go up to the project menu and go to project settings, where instead of sticking to this first general tab, I'm going to go over to the second tab called input map. This is where we can create actions and assign them to keys on the keyboard. Right now, we don't see any actions because we haven't made any yet, but we can actually say show built-in actions to reveal all the ones that came with our project by default. You can see here an action called UI accept, which is bound to the space bar on the keyboard. It's actually bound to, if I get that little prompt out of the way, the enter key on the keyboard as well. So either the enter key or space will make the character jump in my case. You can see there's many more, including UI left and UI right, which have the left and right arrow keys, as well as different gamepad keys automatically built into your project. We have UI up and UI down as well. But what I'm going to do is hide all the default ones and make my own actions. I'm going to type right in here cam_left. This is going to be the camera rotating to the left action. If I press add, I'll add one more, cam_right, and I'll press add. And now that I have these actions, I have to bind a key on the keyboard to them. To do that, I simply go next to each one and press this plus, where Godot will actually be waiting and listening for the next key or key combination that I press on the keyboard. If I press for the left cam action, the letter A on my keyboard, I'll tap A. It'll recognize that, and now all I have to do is press OK. So now the A key is bound to cam left. I'll do the same thing for cam right. I'll press the plus, I'll press the D key on the keyboard and press OK. So now we have those actions that we can check for in code. I'll go ahead and press close because in my game character's script here, what I'm going to do is add a couple of if statements. We're going to put these if statements right inside of our game loop physics process delta right here. I'm going to make a new section here with a little header. I'm going to say rotate the camera left and right. In this section, I'm going to write a couple of if statements. I'm going to say if input dot is action just pressed. If I use this first method here like that, you can see that it'll prompt me to enter in one of my already defined actions. I'm going to use the first one here, cam left, and I'll press enter. This means if I've just pressed the cam left key on my keyboard, what do I want to do? Well, I'll put a colon at the end of this line, as you always do for an if statement, and I'll press enter. What I want to do next is say actually rotate that camera controller on the y-axis a little bit. Let's go ahead and do that. What I'm going to do is select this node from Steve's code by putting, again, a $sign. We learned this in the last few lessons in this course. If you use a $sign, you can name a node, which is a child most likely, of the node with the code that we're currently typing on. So if I type a $sign, I can start typing the name of that node, camera controller. It'll prompt me for what it thinks that I'm typing, and I'll press enter. If I take that camera controller in this code here, I can then type a dot and access any of its methods or any of its properties. In this case, this camera controller has rotation properties, and just like we've seen a few times before in this course, there's also a method built into it called rotate_y for local Y rotation, which is exactly what we want. So I'll press enter there. How much do we want to rotate every time the user presses the left camera key, which is letter A on the keyboard? Well, I'm going to try out 30 degrees. So I'm not going to type 30 in here because rotate Y is expecting not degrees, but radians. I don't know what 30 degrees is in radians, so I'm going to convert 30 degrees into radians by calling that function called deg to rad, degrees to radians. We've seen this before. Degrees to rad, and I'll type in 30 for 30 degrees, so it'll convert that into radians and then make our camera actually rotate in that amount. I'm going to be lazy and copy and paste these two lines, which, by the way, your if needed to be one tab in from the left of your text editor, of course. And when I copy these two lines, Control-C and press enter, I need to make sure I backspace once to make myself lined up with the other if before I paste my next if. Okay, make sure you're all lined up and typing this properly indented. Okay, so I'm going to say if I press the cam right action key, I want to rotate negative 30 degrees. In fact, I think I'm going to do negative 30 for left and positive 30 for right. I think that'll be more correct. I'll press Control S to save. I will go back to my level 1 tab, and I'll go ahead and press play scene. So now if I press my movement arrow keys, those still work. However, if I press the A key, my camera will rotate to the left and the D key will rotate to the right, and I can rotate my camera all the way around. Isn't that nice? However, if I press my arrow keys at this point, when I'm looking at my scene from a different direction, well, the up arrow key still moves to the original forward direction. If I press the left arrow key, it still moves to the original left direction, and therefore the movement is not in relation to my camera, which is what I want. Because if I rotate the camera all the way 180 degrees around, if I press the up arrow key, I want the character to move forward in relation to my current view and not the original forward. If I press the right arrow key, I want the character to move right on the screen, which would be in the opposite direction from what it just did. So it's not moving my character in relation to my camera. Let's go ahead and fix that. I'll go ahead and close my output dock at the bottom. The code that I want to edit to do this is a few lines down here on line 27 and line 28 in particular. I'll go ahead and maximize my workspace so you can see all of those lines of code. Well, line 27 takes the arrow keys pressed by the user on their keyboard, and it kind of averages them out to figure out which direction to move in and saves that direction in what's called a vector2 variable, which stores two numbers, two directions, an X and a Y value, and those are okay. However, what it's suggesting to us in the code that Godot gave us is, well, this code gets the input direction and handles movement acceleration. Well, that second part is this line here. However, what it's suggesting to us in the next line is, as good practice, you should replace UI actions with custom gameplay actions. So it's given us these default actions, UI left, UI right, etc. It's saying that we should probably make our own actions with our own names, like left and right without UI, and forward and back perhaps. Now that you know that, I think it would be good practice for you to actually implement that for yourself. In the case of this lesson and this course, I'm going to leave them the way they are, but it would be good practice for you. Okay, I've gone ahead and said that. I'll go ahead and actually get rid of this line of comment right there so that it's not cluttering up our code. The code that I need to edit right now is this line. This line determines our direction. In other words, it takes the input from the user as well as our cube's direction, and it combines them together to figure out which direction you should actually move in. It's this line that I need to edit right now to make it in relation not to how our cube is facing right now, but actually how our camera is facing right now. So I'm going to up here put a comment for this one line of code. I'm going to say it's a new vector 3 direction taking into account the user arrow inputs and the camera rotation, like that. Now, what is this thing called transform.basis? Well, without getting into too much mathematical detail, there is quite a lot of math in terms of 3D geometric math to learn in order to fully understand what's going on here, which is beyond the scope of this course. What you should know is that every 3D object in a game, in a 3D game level, has a bunch of transform properties. If I go back to my 3D scene and I go into Steve's scene and I select, let's say, Steve's mesh object, well, we can go over to the mesh's properties here in the inspector and down to this transform section where every 3D object has a position in the X and Y and Z directions. This is essentially a vector 3 value. It has a rotation, an X, a Y, and a Z value for that as well, and a scale. And every object has what's called an origin. An origin is essentially the dot in 3D space where it keeps track of where that object is with one coordinate. It's essentially where your gizmo, your on-screen handles, meet at the middle of your object. So there's actually quite a lot going on here mathematically. Again, I'm not going to get into it, but essentially your character's transform is all of those things in one. It's actually a type of class in Godot. You can actually dive into that class by holding Control and clicking on that name transform, which will jump you into this object's transform. We are right now in the class called Node3D because everything that inherits from a Node3D will have this transform class as one of its variables. Now, this transform class that I just mentioned, if I go ahead and click right here, I happen to have found it in this paragraph. If I click on the transform 3D class, you can see that it also has something called a basis. And a basis is how that object is currently rotated without taking into consideration its origin location. That's a separate part of a transform. You see how it gets quite deep into 3D geometric math. I'm not going to go any further with that. What I'm going to tell you though, I'll go ahead back into Steve's code and maximize my script workspace here. What we have to do here is instead of making the direction of my character in relation to my character's rotation in 3D space, along with the keys, the arrow keys pressed on the keyboard, I'm going to take this basis of my character, which it's referring to in multiplying it with the direction of our arrow keys, and I'm going to change this to instead be the basis, which means the rotation of my camera controller. So I'm going to put here a $sign and say camera controller dot transform dot basis instead. Let's go and see if that does anything that we want. If I press Control S to save and then go back to my level 1 scene tab, if I go up to play scene, how does it work? Well, if I press the left and right and up and down arrow keys, my character still moves the way that I expect him to. However, if I rotate the camera with the D key on my keyboard and the A key, well, if I press the up arrow key to move forward, hey, look, the character actually moves forward in relation to how the camera is facing. If I press the down arrow key, it works. If I press right, it works. Left, it works. And any direction that my camera is facing, if I press up, left, and right, and down, it moves as you'd expect in relation to the camera. So hey, it works. But one thing you'll notice is that when I'm playing my game, because our game character is just a cube right now, it's hard to see this, but as I'm moving around my game level with my camera at different angles, well, the character isn't looking in the direction that he's moving. If I rotate my camera around and then press the up arrow key, my character should probably turn or at least snap to face the way that they're actually going to be walking. So if I press the left arrow key, my character's face needs to face to the left. And if I press down, the character's face should face towards us because that's the direction that he is currently moving when I press the down arrow key. In order to actually test this out and for us to code this with any accuracy, we need to give our character a little face. Now, in a few lessons from now, we're actually going to bring in our actual robot game character. However, right now, I'm just going to go into my 3D workspace and I'm going to jump into Steve's scene here. So I'll click the little clapboard scene icon and I'll make my view just one viewport here under the view menu, one viewport. What I'm going to do is take my mesh instance, which I'm actually going to rotate itself. I'm not going to rotate the entire character to face in the way that he's moving. I'm just going to rotate the mesh. What I'm going to do though is give my mesh a child. We're going to put a little simple face object on the character's front. So I'm going to select that mesh instance 3D in Steve's scene. I'm going to press plus. I'm going to add a new mesh instance 3D. So I'll search for mesh, or I'll just go down here and double click on mesh instance 3D. This mesh instance, which is a child of our original mesh, I'm going to name this face. We're going to put a simple round cylinder on the character's face. Which direction is the front of the character? Well, in Godot, forward is usually on the negative z-axis, which is in the opposite direction of the forward z-axis, which is the blue arrow. So the character's face is over here in the negative z direction. So with this face mesh selected, I'm going to go ahead and give it a simple cylinder mesh shape, and I'm going to rotate it. I'll hold down the control arrow key to snap, and I'm rotating it on the x-axis to spin it to face the front, or a circle to face the front on the negative z direction on that blue line there. And I'm going to use my scale tool. I'm going to scale this circle down. I'll hold shift on my keyboard and grab this little green square there to scale it uniformly with the shift key down to be still round but smaller. And then I'll grab this scale tool gizmo and make it thinner like that. And now I can use my arrow tool to put this round cylinder on the front of my character. It kind of looks like Thomas the Tank right now, if I don't say so myself. So that's the character's face. I'll press Control S on my keyboard. If I go now into my level 1 scene, you'll see that because my character is facing away from the camera at the beginning of the game, that's in the right location. So if I press the play scene button, you'll see that when I press forward, that face is facing away from me. However, when I press down, it should face towards me, and it's not right now. Let's go ahead and fix that. In my character's code, I'll jump back to Steve's code here and maximize my workspace. I'm going to add one more section into this code right above all of this actual movement code that we got earlier in this course from Godot. So right under the line that we just edited a few moments ago, I'm going to make a little bit more space, and I'm going to make a new heading here that says rotate the character mesh so oriented towards the direction moving in relation to the camera. That's a pretty long description, but I kind of like it, so let's type it out. What I want to do here is actually write an if statement, because I only want my character to face in the direction that they're moving if they're actually moving. When are they moving? Well, they're moving whenever the user is pressing keys, arrow keys on the keyboard. So what I'm going to do here is say if, and we have made, or actually gotten, this input direction variable, which is a vector2, from pressing the arrow keys on the keyboard. But this vector2 will be essentially a vector2 with two empty X and Y properties, or an empty X and Y with 0, 0, if the user is not pressing anything. But if they're pressing, let's say, the right arrow key, well, the first value, which is the X value, will probably be something like 1. And if they're pressing the left arrow key, it'll probably be -1. But if it's 0, 0, it means they're not pressing anything. So I'm going to get rid of that line, because what I want to do is say if my input underscore direction variable is not equal to, that's how you say not equal to, exclamation mark equals. Recall that if you want to check for equality, if you want to see if two things are equal, you put equals equals. But if you want to say not equal to, it's exclamation equals. If the input direction is not equal to a vector 2 that has both 0 values, which means that they're actually pressing one of the arrow keys on the keyboard if this Boolean expression is true. What do I want to do? Well, I want to take the mesh, which is $mesh instance 3D, which is my character's cube, and I want to change its rotation in degrees. So I'm going to say rotation underscore degrees, which is a vector 3. It's right down there, and I'll press enter. It's a vector 3 that contains 3 numbers, the rotation in degrees on the X, Y, and Z axes in that vector 3. And I'm going to say .y, because I'm only concerned about rotating my character on the Y axis here. And I'm going to make that equal to the rotation on the Y axis of the camera controller, with a few more additions. So I'm going to say $camera controller dot rotation underscore degrees, like this, .y. And through some guessing and checking, to be honest, I figured out that if you subtract from that the input direction as an angle, you'll get almost what you want. So if I say here, input underscore direction, but input direction is a vector 2, so I'm going to convert input direction to an angle. So I'll say dot, and there's a method built into input direction, a vector 2, called angle. So I'll just arrow down once and press enter. That'll convert input direction into an angle, but it's in the wrong format. It's in radians, and I want degrees. So I'm actually going to put round brackets or parentheses around all of that there. And I'm going to convert all of that into, can you guess it? I'm going to call radians to degrees, which is the opposite of the method that we've been using quite a bit, called degrees to radians. This is the opposite, radians to degrees. Let's see if that does what we want. I'm going to press Control S on my keyboard, and I'll go up with my level 1 tab selected, and I'll press play scene. What happens here? If I'm looking at my scene through my default camera, if I press up, well, and down and left and right, the character moves in the right direction as it should. However, you'll notice that my character's face, that little gray cylinder, it's not doing exactly what we want. If I press the up arrow key, that face faces to the right. It's 90 degrees off. If I press to the right, it goes down. And if I press left, it goes up. And if I press, well, any of the directions, it seems like it's almost there, but it's just off. Let's try working with that 90-degree hypothesis that I just worked out. If I press up, it goes to the right. If I press right, it goes down. If I press down, it goes to the right. Well, sorry, I meant left there. If I press left, it goes up. It's 90 degrees off. So I'm going to simply add to the end of this, to the very end of that line, plus 90 degrees. Let's press Control S to save and try that out. Again, this was just a lot of guessing and checking on my part. I'll press play scene. And now if I press the up arrow key, down arrow key, left arrow key, and right arrow key, it all seems to work. But the test is, if I rotate my camera, let's try some diagonal angle. Does it work? Yes. If I press down, it faces me left, right, forward, or up. If I orbit around to some other view, it looks like it's working pretty well. You'll notice that my character is not tilting when he moves up a ramp. We're going to fix that in the next lesson in this course. However, I think we've done pretty well in this lesson. We've made it so that our camera can rotate around our character The character moves in relation to the camera, which makes exploring my world a lot more fun. If I rotate my camera around, I can see what direction he's moving. We've made it so that our gravity is increased in the scene. So if I press jump, it falls a little bit snappier. We've also increased the jump force. You might notice that depending on how you set up your game level, you might have made platforms that are too low down or too high up. I can't actually reach that platform. So the last thing I'll do in this lesson is I'm going to go back into my 3D workspace and I'm going to select that grid map in my level. And I'm just going to add a few more steps. I could move this platform down, but I think to save time, I'm going to grab this short little block. I'm going to hold Control and scroll up. So I'm placing a block right on that level. I'm on level 1 of my floor right now on the Y-axis up and down. I'll put a block right there, and then I'll hold Control and scroll up once and put a block right there, I think. So now we have these nice little steps. And let's see if that works. I'll press Control S to save, and I'll press Play Scene. Now if I go over to this part of my game level, there we go. I can jump over to this platform. I can rotate my camera. I can jump onto this platform. I'll rotate around. I can jump onto that platform. There we go. So I think that's going to be it for this lesson. As always, thank you so much for watching. We'll see you in the next one. Bye-bye.